graphs on the back. What's different about this than the other side? What about them? What's different about this picture than the pictures were on the other side? Say it again. Okay, it doesn't have like numbers. It doesn't have like, you can't count. Why do you think that is? Is there something different about the actual graph? What's different on the ends of the graphs? Arrows. Okay, so these graphs go on forever. Whereas on the other side, they stopped at specific points, right? These ones go on forever, which does make you have to be a little more theoretical. Okay, you can't just count in either direction. So in example 1, in this example here, domain and range, I still want to look left and right, but I have to sort of extend out to infinity, and I have to say, will this eventually hit every single number? So if I go to the left of my graph over here, is my graph eventually going to hit my pen? Yes. If I were to go way out to the left, would it eventually hit it? Yes. Assuming that my pen was infinitely long. Okay? So it's eventually going to hit everything to the left of the graph. What about to the right of the graph? Eventually going to hit everything?
Yeah.
Okay. So if it's going to hit everything, what do we say our domain is? All real numbers, yep. And you'll see that here. Okay? For range, I'm going to do the same thing, but going up and down. So I'm going to say, going up, will my graph eventually hit everything above the graph?
Yeah.
Yeah. How about below?
Yeah. No.
No. What's my lowest point?
Oh, it's right there. 0.
0. Okay. So I hit everything 0 and above is what I want to say. So they wrote it as positive reals including 0. I would probably just write it as all real numbers greater than or equal to 0 because I want to include 0 and do everything above it. Okay? Pick another one on this page. It looks hard.
No. 9.
Okay. I will do 8 or 9 in just a minute, but those are kind of weird, so pick a different one.
1.
Really, 1?
Yeah. 4.
Okay.
4.
Oh, 1's harder than 4.
Yeah.
Not. Actually, I don't know if it really is harder, but they're actually exactly the same. So, okay, so number 1, going left and right. So to the left, is this eventually going to hit my pen?
No.
Eventually. I mean, it's going to have to carry down a ways, but it would curve outward and eventually hit it. How about to the right?
Yeah.
Okay, so does it hit everything?
Yeah.
So what's my domain? Okay. Let's go up and down. Above the graph, is it eventually going to hit?
Yeah. Oh, yeah.
Below?
Yeah.
So what's my range?
All
All real numbers. Good.
So if they're almost the same, that means number 4 is the same, right? Yeah.
This one's just curvy, but it's got the same idea. All right, let's look at either 8 or 9. You pick. Which one's harder?
9.
9?
9.
Okay. Check out number 9. Okay, so number 9. To the left, am I eventually going to hit?
Yeah.
And to the right, am I eventually going to hit?
Yeah.
But do I hit everything in between?
No.
Where do I stop? Where's my gap? What number? 0, yeah. Right here at 0, at x equals 0, my graph's never going to hit that. Okay? So I'm going to hit everything positive and everything negative. I'm just not going to hit 0. And so I would say for my domain,
All real numbers plus 0.
very good, all real numbers except 0. What about my range?
Oh, no.
Up and down?
Yeah, you're going to hit.
Same
all real
thing.
Numbers,
All real numbers except
0.
0. Because again, I have that issue. I can hit everything above and everything below, but I have a gap right here in the middle. Okay? So I'm not going to hit 0. And so my range would be all reals except 0. Okay, so homework tonight is to finish both sides of this worksheet and to go back to Lesson Master 1-4 and try 4, 5, and 6. Okay? Attempt those problems because now you know how to do them. Okay? One more thing I want to show you.